This video is to talk about the location of the focus or the foci for the hyperbola function. We've already done a lot of work with the hyperbola function, but we haven't really talked about where exactly the focus or the foci are located. We do know that it's kind of located here. If you remember the investigation, I had a planet here and I had a moon here, and we were flying between the planet and the moon. So we knew that the planet was kind of, located close to the vertex here. But as you found out in the hyperbola foci investigation, you found out that it turned out that the distance from the center of the hyperbola to the corner of the rectangle happens to be the hypotenuse of this right triangle, right? And this distance here also happens to be the distance to the focus, okay? So if you want to figure out the distance to the focus, given a hyperbola, all you need to do is figure out the distance for the hypotenuse of this right triangle, which you can find out, of course, by Pythagorean theorem. So, for example, in this particular case, A is 4, B is 3, okay? And so if this is 4 and this is 3, I could do 3 squared, which is 9. I could do 4 squared, which is 16. I add them together, I get 25. And so C squared is 25, which means C is the square root of 25, which is 5. This is a very special triangle. It's the 3, 4, 5 triangle, which happens to be a right triangle, and all of the lengths of the right triangle are whole numbers. That doesn't happen too often. So I made this one so that it would work out perfectly, but of course sometimes it's not going to be a nice whole number. But anyway, Pythagorean theorem is always going to work for you to find this distance from the center to the focus. Notice that this length is 5, and the length from 0 to the focus is also 5. Okay? So now I'm going to show you a couple examples with equations. So here we have Pythagorean theorem, a squared plus b squared equals c squared. In this case, a and b have special meaning, right? A and b are the half width and half height of the special rectangle of the hyperbola. And c squared is both the hypotenuse of the special triangle here, the distance from the center to the corner of the rectangle. It is also the distance to the focus. So once we figure out C, we can just add C units to the center in the x direction in this case, and we find out the focus is at 5, 0. We can do the same thing if we have this kind of top bottom hyperbola. In this case, even though it is in a totally different orientation, it is also 5 units away. Okay, it's the exact same orange rectangle here, right? And in this case, I have a top-bottom hyperbola. This top-bottom hyperbola also has the focus 5 units away from the center. In this case, of course, it's not going to be 5, 0. It's going to be 0, 5 because the hyperbolas are on the top and the bottom. Okay? So, here we have a hyperbola equation. And as you know, the standard form is x squared divided by a squared minus y squared divided by b squared equals 1, okay? And you know that if it's x squared minus y squared form, and there's a positive 1 here, that means that this is a left-right hyperbola, kind of like this one here, left and right, okay? So, if I was to sketch a graph for this, I would say, well, first thing I'm going to do is I'm going to figure out what the rectangle size is. If 9 is a squared and 16 is b squared, that means a is equal to 3 and b is equal to 4, correct? And if I know that a equals 3 and b equals 4, then I know that c is going to be equal to 3 squared plus 4 squared square root, which is 9 plus 16, 25, divided square root, which is 5. Okay? So for this particular hyperbola function, the c value is 5. Okay, if I know the c value is 5, if I'm going to sketch this hyperbola, I would draw the rectangle. Oops. And the rectangle is going to be, let's see, it's going to be 3 half width here, and 4 half height there. And then the distance from the center to the corner of this rectangle is going to be 5 because that's the C value, okay? And it also turns out that the distance from the center to the focus is also going to be 5, right? Because we know that the distance to the focus is also C. And if we were going to sketch this hyperbola, it would kind of look like this. And we know it's a left-right hyperbola because what we said, x squared minus y squared equals 1 is the standard format for a left-right hyperbola. So it would look kind of like this, and the focus would be located at 5, 0, and there's another one here at negative 5, 0. Okay? All right, let's move on to another example. This one here is a little bit different. Instead of x squared minus y squared, I have y squared minus x squared. Another way you might see it is if you see x squared, 25, minus y squared over 144 equals negative 1. This is the exact same equation as that. Okay, I just multiplied both sides by negative 1. Okay? Now we're going to go back to look at this. Okay. So if we look at this, we know that the a squared value is actually underneath the x squared value. So this is a squared and this is b squared, okay? So the a squared in this case is 5, and the b squared in this case is 12, right? So let's figure out what the c squared value is here. Okay, so the c squared value is going to be a squared plus b squared. That's going to be 5 squared plus 12 squared, which is 25 plus 144. 25 plus 144 is 169. C would be the square root of 169. If you look on your calculator, it turns out that the square root of 169 is 13. Okay? So in this case, this is another special triangle. It's a 5, 12, 13 triangle. If I was to sketch this hyperbola, I would draw the rectangle first, right? Centered again at the origin, 0, 0, because there are no h and k values here. And I am going to make it, I'm going to make it taller than it is wide, because in this case the x value is, the a value is 5 and the b value is 12, right? So this would be 5 and this would be 12. And then this hypotenuse would be 13. Okay? And if this hypotenuse is 13, that means that the distance from the center to the focus is also going to be 13. Now the question is the focus going to be over here or is the focus going to be over here? Well, in this case it's a y squared minus x squared parabola, which means it is a top-bottom parabola. So that means the focus is actually going to be above and below. So I'm going to say that the focus is going to be here, and the focus is going to be here. The location of the focus is going to be 0, 13, because the height of the focus is going to be 13 units away from the center. And then I'm going to draw my asymptotes kind of like that. And then I'm going to sketch my oh, that was awful. There we go. And there we go. And then, so you can see that the focus is close to the vertex, but it's inside the hyperbola. Okay? So we have found the foci location, again, by finding the C value. One last one. In this case, we actually have a translation here. There's a translation in the x direction, right? A h value that's here. The h value turned out to be 2, okay? So there is a horizontal translation here. Let's first just look at the a and the b value again. The a value is here and the b value is here, right? So the a value is going to be 8. The b value is going to be 6. Let's figure out what the c value is. So the c value would be the c squared value would be a squared plus b squared. A squared is 64. B squared is 36. If I add those together, I get 100. So c is the square root of 100, which turns out to be 10. Okay? So let me sketch again the rectangle here. So in this case, the rectangle is going to be wider than it is tall because the distance A is 8 and the distance B is 6. And the hypotenuse of the this little triangle here is going to be 10. So the question is the foci up here and down there, or is it to the left and right? And in this case, we have an x squared minus y squared equals 1 pattern, which means it's a left-right hyperbola. So that means that the foci are going to be left and right, and they are going to be located 10 units from the center. Okay? Now the thing is, in this case, the center is not 0, 0 because we know that the h value is 2. So the center in this case is 2, 0. So if we were going to generate 2 foci from 2, 0, we would place one foci 10 units to the left, which would be 12, 0, and we would place the other foci at negative, or let's see, 2 minus 10, which is negative 8, 0. Make sense? Okay, I'm going to just move this. I'm going to move this out of the way so I can finish my graph here. Okay, so here I'm going to draw my asymptotes. And it turns out that this center here is actually at 2, 0. So this foci on the right is actually at 12, 0, and this foci on the left is actually negative 8, 0, right? And this is a left-right hyperbola, as we said before. So the hyperbola graph would kind of look like this, right? Okay, and then of course the center was 2, 0. All right, so with this information, let me move this up a little bit so you can see. Okay, so with this information, I think you'll be able to do the IXLs, no problem.